In this video, we shall learn how to evaluate a double integral. So the double integral may be over the rectangular region or it may be over the any general arbitrary region. So let us consider this example. Evaluate integral 1 to 4 integral 3 to 5 x square y dy dx. Here what we observe is the limits are constants and the region of integration is a rectangular region. So order of integration will be first with respect to y between the limits 3 and 5, and then we integrate with respect to x between the limits 1 and 4. So consider integral 1 to 4 integral 3 to 5 x square y dy dx. Since we are integrating first with respect to y, x square is a constant. So integral y dy between the limits 3 and 5 will give y square by 2 between 3 and 5. And hence integral 1 to 4 x square y square by 2 between y equal to 3 and 5 dx. So it is x square by 2 into, when you substitute the upper limit, it is y square, that is when you substitute the upper limit y equal to 5, it is 25, minus lower limit y equal to 3, if you put, it will be 9. So 25 minus 9 is 16 by 2 is 8. Now integrate x square dx with x square dx, which gives you x cube by 3 between the limits x equal to 1 and 4. So 8 into, substitute the upper limit x equal to 4, so it is 64, and for the lower limit x equal to 1, it is 1. So 64 minus 1 is 63 by 3 will give 21. So 8 into 21 is 168. So this is an example of how we evaluate a double integral over the rectangular region or with constant limits. Now we shall see an example where we evaluate integral 0 to 1 integral x to root x dx dy. So the observations are the limits are not constants here. So one of the limits is a variable limit, and since it is a function of x, it is a limit for the variable y. And the other observation is that the region of integration is not a rectangular region, but it is a region bounded by the curves y equal to x and y equal to root x and the lines x equal to 0 and x equal to 1. So consider integral 0 to 1 integral x to root x x y dy dx, that is equal to integral 0 to 1 x into, again here since we are integrating first with respect to y, keep x as a constant. So integral y dy between x and root x will give integral 0 to 1 x into y square by 2 between y equal to x and root x dx. So it is half is a constant, you can write it outside the integral. Half into integral 0 to 1 x into, substituting the upper limit you will get x, substituting the lower limit you will get x square. So x minus x square. On simplification we get half into integral 0 to 1 x square minus x cube dx, which is half into x cube by 3. When you integrate x square with respect to x, it is x cube by 3 minus integral of x cube is x power 4 by 4 evaluated between 0 and 1, and that is equal to 1 by 24. So this is an example of how we evaluate a double integral with variable limits or over a general region.